All right, so today we're going to talk about a concept called significant figures, and it comes from the measurements that we learned already how to make. So anytime we record data, whether it's volume or mass or time or whatever, we're creating what are called significant figures. And it's kind of a weird sounding term, but essentially what it means is when you look at somebody's data on a page, on a lab, whatever, significant figures are, sometimes we just call them Sig Figs, are digits that can be relied upon, especially when doing calculations from that data. Okay, so for example, if you're listening to the Cardinals game and they say that there are 32,000 people at the game, um, when you hear that number 32,000, there's sort of an understanding that that's just a rough number, that's an estimate, that's a rounded number. It might be good to the nearest 1,000 people. So there probably aren't 29,000 people, there probably aren't 36,450 people. There are around 32,000 people, but it might be, give or take a few hundred, right? It's been rounded. So when we hear numbers like that, we need to be able to analyze them and know how many digits we can actually rely on when it's not quite as obvious as that example. So for example, if I see the number 43 milliliters on a lab report, I know that this is probably from a device like this, from a beaker that only has 10 milliliter increments on it. So it's going 20, 30, 40, 50, 60, etc. Because I already know that a scientist or a chemistry student would estimate one digit. And since I can see that this number is 43 milliliters, I know that that 3 was estimated. And so the beaker must have been, must have had increments of 10 milliliters because they estimated that 3 in the ones place. The same way I know if I see 545.20 grams, I can tell that, well, they've estimated that zero. They've estimated the hundredths place in this case. And I know that because the zero wouldn't be there if they weren't able to estimate to that level of precision. So I might, be able to kind of tell that the balance looked like this, 545, and then, it's got tenths or 0.1 gram increments as its smallest lines on the scale. So that, and I know that because they went to the nearest hundredth. They estimated a digit. Okay, so when you're looking at digits, when you're just looking at numbers and you don't have the balance or the graduated cylinder or whatever in front of you, how do you know which ones are significant? How do you know how reliable the numbers are? Well, there are a couple rules I'll give you. Number one is all non-zeros in any number that you see are considered sig figs. They're considered significant. So 1.38 grams, right? That is all non-zeros. So you would say that has 1, 2, 3 significant figures, or 3 sig figs. Another rule is if we have captive zeros, they are significant. And a captive zero would be like the zero in between the 5 and the 2 in the number 502 seconds. So captive zeros exist in between the non-zeros. So this number also has 1, 2, 3 significant figures. By the way, the other thing, in addition to telling how many significant figures we have, we could also say how precise are these numbers that I've shown you. If you look at what decimal place the last sig fig is in, so for example, in the number 1.38 grams, the 8 is the last sig fig, and it sits in the hundredths place, right? So this number is reliable to the nearest hundredth of a gram, right? The 2 in 502 seconds is in the ones place. So this number is reliable to the nearest 1 second. Then the last one is, and this is the only rule that's kind of tricky, trailing zeros. Figuring out if zeros are trailing, they're going to be significant only if the number contains a decimal. So a trailing zero just means that it comes to the right of the last non-zero. So let's take this one step at a time here. The last non-zero in this number is 5. So reading from left to right, the last non-zero is 5. And then after that, I have 2 more zeros. Those would both be considered trailing zeros. They're there for a reason. They're there to show that this number is reliable to the nearest thousandth of a milliliter, right? So they're there for a reason. They're significant. They're Sig Figs. They're part of the measurement. And so those are trailing zeros that would be considered Sig Figs. However, if you look at the zeros in the number 1,200 kilograms with no decimal, those are trailing zeros, but since the number does not contain a decimal, those are not considered Sig Figs. Now, we don't want to drop them off. We don't want to just like erase them, because then the number 1,200 kilograms becomes 12 kilograms, which is a very, very different mass, right? So this number would only be reliable to the nearest 100 kilograms because the last significant figure is in the hundreds place. You could also say that this number only has 2 Sig Figs, but we keep these zeros there as placeholders, but they're not considered Sig Figs. All right, if we take a look at this one, let's talk about trailing zeros first. We do have a trailing zero, right? We have a 0 to the right of the last non-zero. That's this guy. The number contains a decimal, so this is a trailing zero that is significant. It's a Sig Fig. So obviously the 5 and the 1 are Sig Figs because they're non-zeros, but here we also have a trailing zero and the number contains a decimal, so we have 1, 2, 3 Sig Figs. These zeros out in front are just placeholders, just like these zeros were. They're just placeholders. They're not Sig Figs. They're important to keep. We don't get rid of them, okay? But they're not considered Sig Figs. And, you know, if we have however many zeros we have over here to the left of the first non-zero, those are all just placeholders. The same goes with these guys to the right of the last non-zero when the number did not have a decimal. Sometimes people call these leading zeros, but yeah, they are not considered Sig Figs. All right, here's another one. This number has, of course, the 2 is significant, and then it has 4 trailing zeros. 2 are to the left of the decimal, 2 are to the right of the decimal. Okay, so this can get a little confusing because we're thinking about the decimal and, you know, are these all significant? And the answer is yes, because all 4 are trailing zeros, right? It doesn't matter whether they're to the left or to the right. They're after the last non-zero, right? So they are all trailing zeros, and the number contains a decimal. So it doesn't matter which side of the decimal they're on. If they're trailing zeros and the number contains a decimal, which that would be the case for all 4 of these, they are considered significant. So then, and we already kind of said this, but all other zeros are placeholders. So these are not significant figures. Okay, so the only placeholders we saw so far are these 2 right here, and then these 2 up here. Okay. All right. So here's a little bit of practice for you. You can do this in your notes. Underline, circle, highlight, whatever works for you. Maybe underline and pencil just in case you make a mistake. And then we'll go over each of these. So you're just trying to identify all of the Sig Figs. So just go ahead and pause and take a second to do that. Okay, so let's take a look at the first one, 2,508 milliliters. All of them are significant. Remember, the only question is about the zeros. We already know all the non-zeros are considered significant figures. Okay, so that 0 is a captive 0, so it is significant. Remember to look back at your rules when you're doing this. The next one, 1.70, also all of them, because that 0 is a trailing 0 and the number contains a decimal, right? 150 kilograms, what kind of 0 is that? That is a trailing 0, but the number does not contain a decimal, so it is just a placeholder and not considered a sig fig. 0.045 meters, kind of similar, just has 2 sig figs because those zeros out in front are just placeholders. They're not trailing zeros, so it doesn't matter that the number has a decimal. They're not significant. All right, 9,010 pounds. We have a captive 0 between the 9 and the 1, but that trailing 0, since there's no decimal, is not a sig fig. It's a placeholder. 8,000 kilometers. Those are all sig figs. Again, whether it's to the left or the right of the decimal, if they're trailing zeros and the number contains a decimal, they are significant. All right, and then 0.00500 seconds, just the 5 and the 2 trailing zeros. The ones out in front are just placeholders, so they're not considered significant figures. And finally, the number 10,000 meters. The comma is not a decimal. It's not the same thing. It's just there to help you read the number more easily. So it would just be the 1. So that one only has 1 sig fig. Now, we've talked about significant figures. We really haven't talked about why yet. And what it comes down to is knowing where to round our answers when we do calculations. And so that'll be the next step that we talk about next time. All right, guys, we will see you next time.